Recently, the GTX Great Train Express, a line of the Greater Seoul Metropolitan Area Express Railway, which connects Onjeong New Town in Paju, Gyeonggi Province, to Seoul Station, was opened. GTX A is 3 times faster than the subway, thanks to advanced train chassis technology and its deep underground placement at the 8th basement level. To achieve higher speeds, it must avoid contact with existing urban rail networks, power lines, and other infrastructure. Today, let's explore the world of high-speed bullet train technology. Hyperloop, overcoming ground, friction and air resistance. Generally, airplanes, which fly in the air without friction, are faster than trains. No matter how fast a train runs, the air density at high altitudes where planes fly is only about 20% of what it is on the ground, meaning air resistance is relatively lower. Therefore, for ground transportation to compete with airplanes in terms of speed, it must overcome both surface friction and air resistance. The dream solutions for these challenges are magnetic levitation, maglev trains, and Hyperloop technology. In early February of last year, a Hyperloop maglev train developed by a Chinese company recorded the world's fastest speeds. It is also known that Canada is developing a train that could carry 54 passengers and run at 100 km/h. How are such speeds possible? Firstly, maglev trains eliminate surface friction. This is achieved by using strong magnetic forces, repulsion between the same poles, and attraction between the different poles between the train's magnets and the coil circuits on the tracks, which acts as a magnet that changes the plus polarity. The repelling force between like poles lifts the train about 10 cm above the track, while the alternating polarity plus of the coil circuits generates an attractive force. That attractive force propels the train forward. However, air resistance remains a challenge. This is where Hyperloop technology comes in. Hyperloop involves constructing deep underground tubes, the roads where the trains run, and removing air from them, creating a near-vacuum environment where air resistance is nearly eliminated. Inside these tubes, a capsule-shaped train called a pod is installed and propelled using maglev technology, completing the Hyperloop setup. This setup mimics the conditions of an aircraft flying at a 10 km altitude, and in theory, it could allow speeds of up to Mach 3.